Hello all, this is Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. Today we are going to discuss about segmentation. In previous videos we have discussed about image restoration and segmentation, and now we are going to discuss about segmentation. In the segmentation part, first we are going to discuss about detection of discontinuities. Okay, see here the example for image segmentation. Our input image, a tiger, and a segmented output image, segmented tiger. Okay, here we are going to discuss about an introduction to image analysis and segmentation part, and detection of discontinuity like point, line, agent, combined detection. And in the future, in the upcoming videos, we are going to discuss about edge linking and boundary detection, like local processing, Huff transform, graph theoretic technique, like that. And thresholding part, we have global thresholding, optimal thresholding, and threshold selection. And in region oriented segmentation, we have region growing, region splitting, and merging. First, now we are going to discuss about detection of discontinuities. Okay, see here in image analysis, the techniques for extracting information from an image, and the segmentation is the first step of image analysis. Here, segmentation is used to subdivide an image into its constituent parts or objects. This step, it determines the eventual success or failure of image analysis. Generally, the segmentation is carried out only up to the objects of interest are isolated, like face detection. The goal of segmentation is to simplify or change the representation of image into something that is more meaningful and easier to analyze. See here the classification of segmentation techniques. Image segmentation, we have discontinuity and similarity. Based on discontinuity, we have point detection, line detection, and edge detection. And similarity, we have thresholding, region growing, region splitting, and merging. See here, we have two classification, discontinuity and similarity. In the discontinuity, we have point, line, and edge. Similarity, we have thresholding, region growing, region splitting, and merging. See, point detection based on the masking. See here the array -1, -1, -1, -1, 8, -1, -1, -1, -1. In the center value we have only 8 because it is a point detection. Find response R. The emphasis is to strictly to detect points, that is differences those are large enough to be considered as isolated points here. So compare and separate based on where R response of convolution, T non-negative threshold value. See here the diagram, it shows the point detection example. Here we have original and image after applying mask and threshold image by T equal to 8. This is used to detect the point. See the final output image. In that image we have 3 detected points. And see here the line detection. Line detection, we have horizontal line, vertical line, 45-degree inclined line, and -45-degree inclined line. See, for horizontal we have horizontal 2, 2, 2, 2, and 2, 3 2s. And the 45-degree we have plus 45-degree inclined line with values. And vertical line, we have vertical line with values, and -45-degree inclined line we have the values in -45-degree. And in this line detection, see here the original image, and here we have horizontal line detection. It shows the horizontal detected line. For vertical line, the only vertical line is shown here. Plus 45-degree, we have 45-degree inclined line detection, and 135-degree inclined line detection is shown here. See how it differentiates the lines like horizontal, vertical, plus 45-degree, -45-degree, and other degrees of lines. And the next one is edge detection. In this edge detection, we have different types. First one is robot mask, prefit, and Sobel operator. We have Laplacian too. See here in the robot mask, we have only 2 cross 2 with -1, 1, 0, 0. Same for a privet, we have 3 cross 3, and for Sobel we have different values in the rows. Laplacian it is like point detection. We have the values in the center only. Based on the application, we can select either robot, pivot, Sobel or Laplacian. We have so many edge detectors. Okay, see here the original image. Sobel horizontal edge. First we detect the horizontal edge with the help of Sobel mask, Sobel operator, and Sobel we have to do some analysis for vertical edge. So we have both horizontal and vertical edge, and finally the Sobel edge is detected. Finally we will get the original image edges with 4 corners. First one is to detect horizontal edge, second one is to detect vertical edge, and finally we will get the Sobel edge, the original edge of the image. See here the original image. Here we have Laplacian to unsharp the image, and after thresholding we will get the edge. Based on the application we can choose the operators, that is edge detection operators. And what do you mean by this combined detection? Multi-mask formulation makes a possible development of a method to determine whether a pixel is most likely to be an isolated point or a part of a line or an edge. So here we have combined detection. See here. First one, see the second one, see the third one and fourth one. See the last one. Based on the Ferry and Chen filters, we can use combined detection. Okay, what is this edge linking and boundary detection? Intensity discontinuity can be utilized to find boundary. The lagging part of boundary detection using intensity discontinuity is that the boundary may not be completely defined because of noise and breaks in boundary due to non-uniform illumination. So, after edge detection, edge linking process is carried out to assemble edge pixels into meaningful boundary. See here, the need of edge linking. The boundary is not completely in edge detection, bottom figure. So, we need to link the edges to get meaningful function for edge linking and edge detection. Here we use local processing for edge linking to analyze every pixel in the smaller neighborhood that has undergone edge detection. For some characteristics, pointers on same edge or not, 2 principal properties are used here: strength of the response of gradient operator and the direction of gradient. See here, modulus del f of xy minus del f of x dash y dash, it is less than or equal to t. For the direction of gradient, we have modulus alpha of xy minus alpha of x dash minus y, x dash and y dash, it is less than or equal to a. For this edge linking, we consider the local processing to have the strength of response of gradient operator and the direction of gradient. Okay, the next one is boundary detection. We will discuss about boundary detection in next video. Thank you.